Today, we have to learn to solve exponential equations. So we have two cases, as you can see here. First case, the bases on each side are alike, which means they're already alike. We will find out in the second case that we have bases that are not the same, they are not alike, and we have to change them. But here they're already the same. And by the bases are alike, we're talking about the large numbers. And so in this case, our bases are the same, the threes, and if the bases are alike, then we can take the exponents and set them equal to each other. So 2x minus 2 is equal to 6, right there, see? That's where they come from. And then of course we use regular algebra to work down and solve it for x. If you have a difficulty doing regular algebra manipulation, then put it in and solve, and solve it very easily from there. We have an example right here. I think this is the first example in the, this is not the first example, but notice again, the bases are already the same, therefore we can set the exponents equal to one another. 2x minus 1 comes from here, 7 comes from there. Of course, normal algebraic manipulation. We add 1 to both sides, divide by 2. So x is equal to 4. This is case 2, in which we have bases that are different. Notice please, we have 3 and we have 1/9. We have to find a base that is compatible. Now, here in the example, of course, we have a situation where 1/9 is the same as 3 to the negative second. And if you look at your little sheet that's been handed out to you, you could look it up, and 1/9 is equal to this, so you know what to put in. You're looking for that combination that makes the bases the same. We now have both of them as 3's. From there, it's just like the situation we had previously. Once we have the bases the same, then the exponents can be set equal to one another, and we can solve it for x. And of course, regular algebraic manipulation, we add 2 to both sides, and we end up with 2x equals 0. We divide both sides by 2, x equals 0. In this situation here, it's the same idea, except it's just a little more complicated. But we have to be able to write this number. These two bases have to be written as the same, and they have to be the same number. Well, we can look on our little sheet, and we can see that 9 is 3 squared. So this right here can be replaced with this, just like that. We still have the exponent. See, notice all I did was substitute 3 squared for 9. Even here, we just substituted 3 to the negative 2 for 1/9. Equals 3 to the 4th. We have the same base. We can now set the exponents equal to one another. And when you have a power raised to a power, you're multiplying. One of the exponent rules that you should have gone over already. So this becomes 2 times x minus 3. See? 2 times x minus 3 equals 4. Regular algebraic manipulation. 2x minus 6 equals 4. Add 6 to both sides. 2x equals 10. Divide both sides by 2. X equals 5. Again, important, we cannot set the exponents equal to one another until we have the same base.